The builder agents, Alice and Julian, on Minecraft platform, and Mike Smith. They'll share their lessons learned. So let's give them a little more welcome.
Hey everyone, how's it going? My name is Sherwood. I am one of the tech leads here at 11X. I lead engineering for our Alice product. And today I'm joined by Keith, our head of growth, who is the product manager for this Alice product. Now, 11X, for those of you who are unfamiliar, is a company that's building digital workers. We have two digital workers today. The first is Alice. She's our AI SDR. The second is Julian. He's an AI voice agent. We've got more workers on the way.
I want to take everybody back to September 2024. It's, for most people, not long ago. For us, top company history. We just crossed 10 million CARR. We just announced our Series A. Then our Series B, 15 days later. With all this chaos going on, we relocated our whole team and company from London to San Francisco to a beautiful new office with our beautiful new CTO. And at the same time, we also bought a rocket because we're 11X. During all this chaos, we chose this moment to rebuild our core product from the ground up. And the reason we did that is because we truly felt at the time, and proved to be true, that agents were the future.
So today's talk, I want to first tell you why we felt the need to rebuild Alice from scratch. Hopefully, I think everyone's probably in agreement about agents being the future. Then I'll tell you how we did it. We built this enterprise-grade AI SDR in just 3 months. Then I want to talk you through one of the challenges that we experienced, which was finding the right agent architecture. And I'll wrap up with some reflections on building agents and some closing thoughts. So let's start with the decision to rebuild. Why did we feel like we needed to rebuild a core product from scratch at such a critical moment? Well, to understand that question, we first need to understand Alice 1. And Alice 1 was our original AI SDR product. The main thing that we could do with Alice was create these custom AI-powered outreach campaigns. And there were 5 steps involved in campaign creation. The first step is defining your audience. That's when you identify the people that you'd like to sell to. And then the second step, you describe your offer. This is the products or services you're hoping to sell. Then the third and fourth step, you construct your sequence and also tweak the AI-generated messaging. And finally, when everything is to your liking, you move on to the last step, which is you launch the campaign. And that's when Alice will begin sourcing leads that match your ICP, researching them, writing those customized emails, and in general, just executing the sequence that you build for every lead that enters the campaign. Now, Alice 1 was a big success by a lot of different metrics, but we wouldn't really consider her a true digital worker. And that's for a lot of reasons. For one, there was a lot of button clicking, more than you would probably expect in a digital worker. And you also probably saw there was a lot of manual input, especially on that offers page. Our lead research was also relatively basic. We weren't doing deep research or scraping the web or anything like that. And downstream, that would lead to relatively uninspiring personalization in our emails. And there, on top of that, Alice wasn't able to handle replies automatically. She wasn't able to answer customers' questions. And finally, there was no real self-learning component. She wasn't getting better over time. Meanwhile, while we were building Alice 1, the industry was evolving around us. In March of 2023, we got GPT-4, we got the first Claude model, and we got the first agent frameworks. And later that year, we got Claude 2, and we got function calling and the OpenAI API. Then in January of 2024, we got a more production-ready agent framework in the form of LangChain. And in March, we got Claude 3. In May, we got GPT 4.0. And finally, in September, we got the Repl agent, which for us was the first example of a truly mind-blowing agentic software product. And just to double-click into the Repl agent a little bit, this really blew our minds. It consists of 2 things. First, the agents were going to be really powerful. They could build entire apps from scratch. And second, that they're here today. They're ready for production. So with that in mind, we developed a new vision for Alice, centered on 7 agentic capabilities. The first one was chat. We believe that users should mostly interact with Alice through chat the way they would interact with a human team member. Secondly, users should be able to upload internal documents, their websites, meeting recordings to a knowledge base, and in doing so, they would train Alice. Third, we should use an AI agent for lead sourcing that actually considers the quality and fit of each lead rather than a dumb filter search. Number 4, we should do deep research on every lead, and that should lead to number 5, which is true personalization in those emails. And then finally, we believe that Alice should be able to handle inbound messages automatically, answering questions and booking meetings. Also, she should be self-learning. She should incorporate the insights from all of the campaigns she's running to optimize the performance of your account. So that was our vision, and with that in place, we set out to rebuild Alice from scratch. And in short, this was a pretty aggressive push for the company. It took us just 3 months from the first commit to migrating our last business customer. We initially staffed just 2 engineers on building the agent. After developing the POC, we brought in more resources. We had 1 project manager, our one and only Keith. And we had about 300 customers that needed to be migrated from our original platforms to the new one. And that was growing by the day. Our go-to-market team was really not slowing down. There were a few key decisions that we made at the outset of this project. The first is that we wanted to start from scratch. We didn't want Alice 2 to be encumbered by Alice 1 in any way. So new repo, new infrastructure, new team. We also didn't want to reinvent the wheel. We were going to be taking on a lot of risk with some unfamiliar technologies like the agent and the knowledge base. We didn't want to add additional risk through technologies that we didn't understand. So we chose a very vanilla tech stack. And number 3, we wanted to leverage vendors as much as possible to move really quickly. We didn't want to be building non-essential components. This is the tech stack that we went with. I won't go into too much detail here, but I thought people would be interested to see. And here are some of the vendors that we chose to leverage and work with. I can't go into detail with every one of these vendors, but they were all essential to our success, and I wanted to shout everyone out that has been useful. Of course, one of the most important vendors we chose to work with was LangChain. And we knew that we were going to need a really good partner from the start if we were going to pull this off. LangChain was a very natural choice for us. They were a clear industry leader in AI dev tools and AI infrastructure. They had an agent framework ready to go. Cloud hosting and observability, so we knew we were going to be able to get to production, and that once our agent was in production, we would understand how it's performing. We also had some familiarity from Alice 1. We were using the core SDK with Alice 1. And then LangChain also had TypeScript support, which is important to us as a TypeScript shop. Last but not least, the customer support from the LangChain team was just incredible. It really felt like an extension of our team. They ramped us up on LangGraph and the LangChain ecosystem and on agents in general. We are so grateful to them for that help. In terms of the products that we use today, we use pretty much the entire suite. And now I want to talk you through one of the main challenges that we encountered while building this, while building Alice 2, which was finding the right agent architecture. And you'll remember the main feature of Alice was campaign creation. So we wanted the Alice agent to guide users through campaign creation the same way that a Replit agent would guide you through creating an app. We tried 3 different architectures for this. The first was React. The second was a workflow. And then finally, we ended on a multi-agent system. So now I'm going to talk you through each of these, how it works in detail, and why it didn't work for our use case until we arrived at multi-agent. Let's start with React. Well, React is a JavaScript framework for building user interfaces, but that's not what I mean here. I mean the React model of an AI agent, which I think other people have talked about earlier today. This is a model that was invented by Google researchers back in 2022, and it stands for Reason and Act. And basically, what these researchers have observed is if you include reasoning traces in the conversation context, the agent performs better than it otherwise would. And with a React agent, the execution loop is split into 3 parts. There's reasoning, where the agent thinks about what to do. There's action, where the agent actually takes action, for example, performing a tool call. And then finally, there's observe, where the agent observes the new state of the world after performing the action. I guess reactive wasn't a very good name. But as I mentioned, reasoning traces lead to better performance in the agent. This is our implementation of a React agent. It consists of just 1 node and 10 or 20 tools. And it's not very impressive looking, I know, but this simplicity is actually one of the main benefits of the React architecture, in my opinion. So why do we have so many tools? Well, there are lots of different things that need to happen in campaign creation. We need to fetch leads from our database. We need to insert new DB entities and draft emails, and all of those things become the tool. The React loop that I mentioned on the previous slide, that's implemented inside of the assistant node. And when the assistant actually performs an action, that is manifested in the form of a tool call, which is then executed by the tool node. One thing to note about the React agent is that it runs completion for every turn. So if the user says hello, and they say, I'd like to create a campaign, that would be 2 turns, and the React agent runs to completion each time. That's going to become relevant later. Here are some of the tools that we implemented and attached to our agent. Unfortunately, Alice 2 predated MCP, so we didn't use an MCP server or any third-party tool registries. A few things I want to tell you about tools before we can move on. The first is that tools are necessary to take action. So anytime you want your agent to do anything on the outside world, for example, call an API or write a file, you're going to need a tool to do that. They're also necessary to access information beyond the context window. If you think about it, what your agent knows is limited to 3 things: the conversation context, the prompts, and the model base. If you wanted to know anything beyond that, you need to give it a tool, for example, a web search tool. And that's essentially the concept behind React. Tools can also be used to call other agents. This is one of the easiest and simplest ways to get started with a multi-agent system. And last but not least, tools are preferable over skills. So this is a framework I came up with. Essentially, if you think about it, if someone asks you to do something like perform a complex calculation, you can do that either through a tool like a calculator, or maybe you have the skill of the mental arithmetic that's required to perform that calculation. And in general, it's better to use a tool than to use a skill, because this minimizes the amount of tokens you're using in the context to accomplish that goal. What are the strengths of the React architecture? Well, I mentioned one already. That is that it is extremely simple. We basically never needed to revise our agent structure later on. It was also great at handling arbitrary user inputs over multiple turns. This is because the graph is running to completion each time. It allows the user to say something in step 3 that's related to step 1 without the agent getting confused. It's actually robust to that. So that was a great advantage. But it has some issues. For example, the React agent is kind of bad at tools. We've attached a lot of tools, and as you know, what sometimes happens when you do that is the agent will struggle with which to call and in what order. And this would sometimes lead to infinite loops, where the agent is repeatedly trying to accomplish some part of campaign creation but not succeeding. And when those infinite loops go on for a while, we would get a recursion limit error, which is effectively the agent equivalent of a stack overflow. And also the outputs that we were getting from this version of the agent were relatively mediocre. The audiences, the sequences, the emails, they just weren't that good. And our hypothesis here was that because there's just one agent and really like one set of prompts that are responsible for doing the entire campaign creation process, it wasn't really good at any particular point. So what can we do? Like, how can we address these issues? In our case, we chose to add structure, which led us to implementing a workflow. The workflow is defined by Anthropic as a system where LLMs and tools are orchestrated from predefined code paths. This screenshot and quote from, they both come from an excellent blog post by Anthropic called Building Effective Agents. Highly recommend checking it out. I shamelessly lifted it. Importantly, workflows are different from agents, and this is one of the things that the agent community has been debating on Twitter, for example. That's the reason why we have the term agentic for sometimes describing a system as opposed to agent. A system could be agentic, but not necessarily an agent per se. Workflows are highly structured. Predefined code paths. The LLM is not choosing how to orchestrate the code. The LLMs are just calling those predefined code paths. And last but not least, workflows are not really a new technology. We've been for a long time in other forms. And the most famous form is probably the data engineering tool, Airflow. And this was our implementation of a workflow campaign creation agent. It's obviously a lot more complex than our React agent. We now have 15 nodes. They're split across 5 different stages. These stages correspond to different steps of campaign creation that I mentioned before. Interestingly, this graph, unlike the React agent, doesn't run to completion for every time. It only runs to completion once for the entire campaign creation process. And the way that we get user input or feedback at certain points within the graph execution is through the use of something called node interrupts, which is a LangChain feature. There were a number of strengths involved with the workflow architecture. They basically solved all of the problems users are looking for. For one, we no longer have to also got a clearly defined execution flow with a fixed number of steps. So no more infinite loops, no more recursive errors. On top of that, we got much better outputs. The emails and sequences that we were getting from this version of the agent were much better, and that's because you force the agent to go through these particular steps. But the workflow architecture did have issues. For one, it was extremely complex, and now our front-end campaign creation flow experience was coupled with the architecture of our agent, and we would have to change that architecture and that graph structure anytime we wanted to make changes to the campaign creation experience. So super laborious and annoying. It also didn't support jumping around within the campaign creation flow. That's because the graph doesn't run completion over time. When you get to step 3 and you stop using the node interrupt to collect feedback from that step, you can really only respond to what's happening in step 3. You can't jump back to step 1. So really, workflows were not going to be it for our use case. What else can we try? Well, after some soul searching, we came across a blog post by LangChain that explains how to build a customer support agent using a multi-agent architecture. And this is the blog post that gives the insight that we needed for our use case. And a multi-agent system is one that's a hierarchical approach to building an AI agent. In this pattern, there's one supervisor, and there are many sub-agents that are specialized. And the supervisor is responsible for interacting with the user and for routing tasks to sub-agents. When the sub-agents will then fulfill those tasks, and they'll escalate back to the supervisor when they're coding. And we really devoured this blog post by LangChain. We went a little crazy in the process, but ultimately found a version of this that works for our use case. And here's what that looks like. We have a graph a multi-agent graph that accomplishes all of campaign creation except for audience creation, which we have separate for different reasons. And you can see here at the top is our supervisor node. It's close to the start of the graph. And then we have 4 specialist sub-agents. We have a researcher. We have something that generates something called a positioning report, which is how you should position your product or service from this particular lead. Then we have a LinkedIn message writer, and finally we have an email writer. In this multi-agent architecture, it gave us the best of both worlds. We got the flexibility of the React agent, and then we got the performance of the workflow. Now I want to share a couple of reflections on building agents from this experience. And the first is that simplicity is key. All of that structure and scaffolding can provide performance gains in the short term, but over the long term, it locks you into a structure that can be counterproductive. And related to this is that the new model release can really change everything. Amjad from Replit told us this about the Replit agent. He said it wasn't really working until Sonnet 3.5 came out, and then they dropped it in, and everything was magic. And that's really true. It's also useful to think of your agent as a human coworker or a team of coworkers. In our case, if you have different mental models, we thought that the agent was a user flow within our product or a directed graph. Those are the wrong mental models, and they let us implement the wrong architecture. You should also break big tasks down into small tasks. In our case, the big task was the campaign creation, but there were small tasks like writing an email within that. And it became easier to implement the agent once we broke it down into the smaller component tasks. Tools are preferable over skills. Don't try to make your agent too smart. Just give it the right tools and tell it how to use them. And then last but not least, don't forget about prompt engineering. It's easy to forget that your agent is just a series of loop calls within a while loop. If your agent isn't performing well, you should consider going back into this prompt engineering. It might unlock the Sherwood more. And I wish we had time for a demo, but I don't. But I do have this QR code. I'll leave this up for a moment. If you're not able to get to it now, the slides will be available afterwards. You can check out what we've done. Alice 2 went live in January, and now the results have been pretty exciting. She's now sourced close to 2 million leads. I think these numbers are a little out of date. We've sent close to 3 million messages and generated about 21,000 replies. Over the last month or so, her reply rate is around 2%, which is on par with a human SDR. And we're starting to see that climb as we implement self-learning and some other optimizations. In terms of future plans, we're excited to integrate Alice and Julian, our voice agents, so that these 2 agents can engage leads across multiple channels, both inbound and outbound. We're also really excited about self-learning. We've done some work here that I wasn't able to talk more about it. And then finally, we're really excited about applications of new technologies like computer use and memory and reinforcement learning.
Yeah, if any of the this is, sounds exciting, and you're sick of building software, you want to build digital, brokers. Message Sherwood, myself, or anyone with 11x, we need like 11 times as many people, like 11 times as fast. This is a bit of a show, but like, please, like, we need to all get it. Cool. Thanks for listening.
We typically deal with large enterprises, so like big companies across Fortune 500. We have over 115,000 companies, tens of millions of users. Our customers have given us, trust us with over X amount of data. And in many of these companies, we are actually the first AI that they started deployed across the company, partially because many large enterprises are scared of AI, and we were lucky enough to already have been trusted. And so when we do AI, we're always thinking for enterprise grade. Now, when we went to do AI content, we typically would think about it in these different ways, where we had this kind of standard RAG stuff, doing Q&A across a bunch of documents, doing deep research across a bunch of corpus of data. And then data extraction is also a fun feature that we have, so we do extract structured information from unstructured data, in addition to things like AI-powered workflows, like being able to do loan origination, insurance, summary generation, and this kind of thing. But today, to talk about our journey, I'm going to talk about the middle one here for data extraction. We'll talk about how, since we've been integrating our AI into our products since 2023, how we kind of evolved to be more agentic. And I picked this one partially because I think on this list, this is the least agentic-looking type of functionality. There's no like chatting, there's no chatbot associated with it. So this is this interesting lesson that we learned here. So if you don't know much about data extraction, the idea behind it is that many companies have an awful lot of unstructured data. Probably 90% of the data in the world is not data basis in this like unstructured form. And there's a lot of very useful data in it. And so companies always want to get data out of their unstructured data. So this is what we call data extraction or data extraction. And it's a common request for many companies. And many of, there's actually a whole industry here that you probably never heard of called IDP. And it's really oriented around machine learning based systems where you like train a model with a bunch of data scientists to do this kind of extraction. But it really didn't work that well historically. Many companies just, they only automate things that are extremely high scale. It just wasn't very commonly used. And also it would break all the time, very brittle, because if you change the format of anything, it would just kind of, it's not working. So, when generative AI came out, this was like a gift for anybody who knows about structured data, because you can actually just use the power of AI to be able to pull out structured data. So for us, we started with this architecture. Really straightforward. Take a document, take the fields you're looking for, do some pre-processing, and then some OCR, and then be able to give it to the large language model. We say, give me these fields, and it pops it up. You can extract it. This is amazing. When we did this, we immediately deployed it to 10 million pages. The first customer, everything was working, and we got to the point where we were saying, like, this is, can you get a document now? This is amazing. And so it was truly built around the basics of AI on content. And so this was great. It was kind of like generative AI solved. We did it. High fives. But then we started to hit the problems. When we started telling our customers, just give us any data and we'll be able to extract the things you want, like they did. And so they were like, oh, I've never been able to automate this thing before. This 300-page document that was well beyond the context of the time. And we're like, okay, no problem. We'll process more. We built the concept of like an enterprise RAG where we it turns out OCR doesn't work that well in certain cases. People like cross things out, or when you have to deal with different languages. So we had to start to solve that. Then we had this challenge where some people were like, okay, I want not just 20 pieces of data for this document, but like 200 or 500 different pieces, and that just kind of like overwhelmed the attention of the model to be able to pull those things out for you, especially on complex documents. And then people in this world are used to things like confidence. They're like, well, how do I know what's right? What's your confidence score? And of course, generative AI doesn't have confidence scores like ML models do, so we had to like start doing things like, oh, we'll run an LM as a judge, and it'll tell you after it's done if things goes accurate or not. And I was like, okay, sure, but like it told me it was wrong, so why would you tell me if it says it's wrong? So we ended up with all these challenges, and this was like our moment of like the Trump disillusionment of AI, generative AI, because the thing that was working